Recently in one of my weekly live stream videos, I did a kind of long multi-part problem, and one of those parts was talking about how to find the local maximum and minimum values of a function. I thought you might get some use out of seeing that section of that live stream in case you missed it. So in this video, I'm going to be going over how to use the first derivative test to find local max and min values of a function. Now, like I said, this did come from one of my weekly live streams, which I typically do every Monday night at 5 o'clock Pacific time, and it was a multi-part problem. So this video is going to be kind of jumping into the middle of that multi-part problem, where we have already found our critical numbers of this function and figured out our intervals of increase and decrease. And now we're just going to be using that information to talk about where the local max and min values are. If you want to go see the rest of those steps that got us up to this point, I'll put a little info card up there at the top of the screen. I think it's over there. So you can go check that out before watching this video. But if you feel pretty good about critical numbers and finding intervals of increase and decrease, this video is just going to kind of take that a step further and show you how to use the first derivative test to kind of interpret that information to figure out which critical numbers are going to be local maxes and which critical numbers are going to be local mins. I'll also touch on how to know if these critical numbers are neither local maxes or mins, so you can apply that to other problems as well. If all that sounds good to you, be sure to stick around to the end of the video, and if you do get some value along the way, do me a favor and hit that like button down below. Anyway, let's go ahead and jump into it and I'll show you what I'm talking about. Now, part B is going to quickly and pretty easily build off of part A. And the reason for that is, let's think about the general kind of shape of our function at this point. We know it's decreasing from negative infinity to negative 1. It turns around and starts increasing when we get to negative 1. And it continues increasing until we get up to x equals positive 1. And then at that point, it turns around and goes back to decreasing. So in general, the general shape of our function, basically, we're decreasing, increasing, decreasing, right? So you can basically see at x equals negative 1, we turn around and start increasing. At x equals positive 1, we turn around and start decreasing. So what that kind of shows us is, if we're thinking about now for part B, let me just go back up here real quick. Part B is to find the local maximum and minimum values of our function. If we know what intervals our function f of x is increasing and decreasing, that gives you a general idea of its shape, right? You can pretty easily look at that and see, okay, if we're decreasing to the left and increasing to the right, that tells us we have a local minimum value at x equals 1, or negative 1, I'm sorry. And then if we are increasing to the left of this point right here and decreasing to the right of it, increasing to the left, decreasing to the right, that tells us, you can see we have a local maximum, right? It's higher than all the other points around it. So basically the first derivative test tells us that. It tells us if we're decreasing to the left, increasing to the right, it's a minimum. If we are increasing to the left, decreasing to the right, it's a local maximum. If, for example, we were decreasing to both sides of a critical number or increasing on both sides of a critical number, like if we had something like this, where we had a critical number right here, we were increasing to the left and to the right, that would not be a local maximum or a local minimum. In this case, the first derivative test confirms that we have a minimum at x equals negative 1 and a maximum at x equals 1. So this would be our answer for part B, where our local maximum and minimum values are. Well, that's really all there is to it. Thanks for sticking around to the end of this video. I know it was a pretty short one, so if you did get some value out of it and you made it to the end of the video like you did, just hit that like button down below. And while you're down there, just go ahead and hit that subscribe button and that bell icon as well. I'll be coming out with the conclusion of this problem, or at least the next part of this problem, very soon, so hit that subscribe button if you want to see it. If you are watching this later, I'll come back and put it right over there so you can click on the next part of this problem right over there. Thanks, and see you next time.